Hey guys, it's me. Today I wanted to make a video which has been requested several times from many of you subscribers about how to do pharmacology medication dosage calculations. That's an integral part of any nursing program. So it's a long video that I've got today. The tutorial video is over an hour long. So this is not necessarily just a video to watch for entertainment's sake. This is more of a video that you should watch if you're looking for information on how to do dosage calculation. So I thought we would dive into it, but before we start, I wanted to say that for drug calculations, there's plenty of ways that you can do them. When I started my nursing program, I had to take pharmacology before I started any other nursing class. That was at least one of the classes I had to take. And part of the pharmacology class was the dosage calculation stuff. And they taught us a way to do it called dimensional analysis. That's something I had never heard of before. It's something I had never been taught before. So I had to kind of learn what dimensional analysis was. And I have to say, it's super easy. Once you can learn what dimensional analysis is, you can set up any pharmacology dosage calculation question. So to begin, there's a few things you'll need to do dimensional analysis for dosage calculations. Three things, quickly. The first thing you'll need is your workbook or some sort of pharmacology book that your class will provide you. This was given to us as part of our pharmacology class. This was our calculations workbook. It was just a printout of about 80 pages, which was kind of our workbook that we had to go through, and it took us step by step through everything we needed to know about dosage calculation. Mine was fantastic. We had our pharmacology class over 16 weeks, and we had the pharmacology exams, but at the same time we had our dosage calculation exams, which were separate. We had 4 of them, I think, and we had to get 90% or better, I think, to stay in the course. And we could take those tests whenever we wanted, as long as we were ready. And of course, there was a maximum deadline. We had to do all the courses before a certain point. So it was recommended to me to take as many of the dosage calculation exams as I could as quickly as possible, because I wouldn't have time later on to care or to focus on the dosage stuff. So every program is different. Yours may be different, but the more you can grasp the dosage calculation stuff, the better off you'll be, because it's going to come up every semester throughout the nursing program. That's the first part. The second part of dosage calculation is memorizing some conversions. That's just inevitable. You have to do it. My program gave us a chart of some common conversions, which we just had to commit to memory. I'm studying in America, so we are dealing with the metric system, which is what most people in the world are dealing with, and it's what the medical industry and field work with. We also work with the American system of conversions, and then we also have to do a little bit with the apothecary system, which is very old and unfashioned. I'm not sure who does that apart from some pharmacists. But anyway, we were given a chart of conversions to know. I went through my chart and I highlighted some things I didn't know. Most of them were conversions between the American and the metric system. So you'll definitely, let me see if I can zoom here. You'll definitely have some kind of chart which will tell you what you need to know, and that has to be converted to memory. Mine was not that big. It was mostly, things like tablespoons to milliliters and stuff like that. So you just have to, and you'll use that throughout your career in nursing. So that has to go into your brain. When you're studying, you can use that, but for your exams, that's an integral part. And the third thing you need to do is have a calculator. You don't need to do any of these calculations by memory or by mind or by pen and paper. A lot of times when you're doing the dosage calculations, you'll have super big numbers to divide. And so yeah, you just need a calculator. That's about it. Next thing I wanted to mention before we jump into it and get started is that two things. Number one, your conversions are super important. I already said that, but if you mess up on your conversions, your whole answer will become wrong. So you need to make sure you've got your conversions down. Figure out what conversions you don't know by memory and memorize those ones. And then the last thing is significant figures. A lot of times every program is different and rounding rules can be different. I think we all learned rounding probably in 4th grade or something, but in nursing programs and in hospitals, they may have different rounding rules. So whatever your dosage calculation course tells you to do as far as rounding, do it and don't forget it, because you can miss so many points just by a rounding mistake, and that's no cool. So that's it. Before we get started, dimensional analysis is basically just a system of putting information that you're given into a formula so that you can cancel out like figures or similar figures and arrive at the solution you're looking for. It's kind of a foolproof way to input all of the information you're given and any conversions you need to do into a simple linear formula and then canceling out similar units so that you can get your answer. I think if you learn how to do dimensional analysis, it's got to be the easiest way to do these drug calculations that I've found. I found myself, we've used dimensional analysis in many courses, several of the nursing courses, and chemistry, and a lot of classes I've found use dimensional analysis, and I keep finding myself wishing that we had been taught this at an earlier age. I think it would have helped with algebra, with many math classes. It's very easy to do if you learn the way to do it. So that's what I'm going to do. So from here, we're going to jump in. We're going to do 12, I think, problems, and I'm going to explain them as we go. As I said, from my explanation forward, it's an hour-long video. So it's a really long video, and a whole bunch of people will probably want to turn off from here. But if you are needing dimensional analysis or dosage information, think of it this way. Hopefully, 1 hour with me will answer all of your questions better, hopefully, or ideally, than sitting through hours of lectures and then trying to figure it out on your own. So take the next hour, have a drink, go to the bathroom, get ready, get your calculator, and for the next hour, I'm going to teach you everything you need to know about dimensional analysis. Okay, so here it comes. Okay, let's get started. To start out, I'm going to give a couple of examples of dimensional analysis using non-nursing information so that you can see sort of how it works if this is new to you. And then after that, we'll get into some nursing-related questions, which are hopefully will cover everything you need to know in order to pass your dosage calculation exams. So let's start with some examples which will sort of introduce you to dimensional analysis and show you the sort of conversions that you will need to be able to do to complete the problems. Okay, so let's start with the basic sort of example, which is if somebody asks how many seconds are in a year. Okay, so the question is how many seconds in a year, right? Okay, so We don't know that, and with this question we're not given any additional information. We're forced to rely on our own knowledge and conversions to figure it out. When you're doing dimensional analysis, you should set up the problem so that your answer, or what you're looking for, is at the beginning. So what we're looking for is how many seconds are in a year, and you can set it up like this. We'll do abbreviations for simplicity, right? How many seconds are in a year? That's what we're looking for, right? So since we have no other information, we have to do conversions to get ourselves where we need to be. So we don't know, normal people don't know how many seconds are in a year, but we do know how many seconds are in a minute. So we can start with that and work our way forward. When you're setting up dimensional analysis, there are many ways you can do it, and there are many you can insert different information at different times. I'm going to show you what works for me, and we'll talk about that as we go. For me, I like to start with what I know and work with conversions before I input the data that I'm provided. You'll see what that means shortly. But when you're doing this, you always want to provide your data so that at the end, after you've canceled out like or similar units, you've still got the units you're looking for on the top, and the units you're looking for on the bottom, okay? And you can only cancel out similar units if they're on opposite sides of the fraction. So you'll see what that means as we go. Let's see. So we don't know how many seconds are in a year, but we know that there are 60 seconds in a minute. So since seconds are at the top of what we're looking for, we'll put that in our equation on the top. So we have 60 seconds in 1 minute, right? We know that. We have minutes at the bottom, but we're looking for years, so we can convert again. We know that there are 60 minutes in 1 hour, right? And this is basically just a little bit of simple algebra. We're cross-multiplying, canceling like units, and working our way across. So you can do it like that. As you go, or once you're done setting up the problem, you should always cancel out like units. And like I said, they have to be on opposite sides of the fraction in order to cancel out. In this first example, we'll cancel them as we go so that you can see. So we already have, on this first information, we have minutes on the bottom. You can cancel that with the second piece of information, which has minutes on the top. The numbers are still there, but we can cancel out the units since they're on opposite sides of the fraction. Sorry about that. Then we can continue, right? So we've got hours still at the bottom. I did not mean to cross that out. We can keep going. We know that there are 24 hours in 1 day, right? We can cancel out hours, and we can continue. Now we have days at the bottom. We know that there are 365 days in 1 year. Okay, so you can do that and then cancel out days and days. Let's look at what we have. We've got all of our numbers here, and we've canceled out everything except for seconds on the top, which is what we're looking for. And at the bottom, we've canceled out everything except for years, which is also what we're looking for. This is kind of a foolproof way to see that you've provided all the information you need to solve the problem. So then you will do the multiplication. You multiply first across the top and then across the bottom, right? So if you multiply 60 by 60 by 24 by 365, it gives you a huge number, which is 31,536,000, and that's it. And then obviously at the bottom you've just got ones, so you've got 1. If you had a number other than 1, you would have to divide these two, since it's a division sign there, but it's not. It's just over 1, so your answer is right here, 31,536,000. And you should always complete your answers by adding the units. So what you've just done is found seconds per year. And there you've got your answer. 31,536,000 seconds in 1 year. And that is what dimensional analysis is. That was a bit of a lengthy explanation, but in case you've never seen it before, this is the simple way to get from what you're looking for, taking what you've got, adding your conversions, and coming to a conclusion. We'll quickly do another example. Let's say that you have a patient who weighs 65 kilograms, and your question is simply how many pounds does that patient weigh? If you don't live in America or the UK, probably you don't need to worry about this, but we do in America. So pounds to kilos conversions are very common. This is where your conversion chart that I mentioned comes in, and you need to memorize a lot of those simple conversions. So the question is, you always ask yourself first, what is the question? We're looking for pounds, right? So we can set up the question by writing pounds equals, and the only piece of information we have is 65 kilograms. We have to get somehow from pounds to kilograms. Well, what do we know? You know that if you have any basic piece of information like this, like 65 kilograms, we'll write it over here. You can always put it over 1. It doesn't change the value. Okay? This you've probably learned in high school. So 65 kilograms or 65 kilograms over 1, it's the same thing. Anytime you have a simple basic unit that you need to add into these problems, you can always put it over 1 if you need to in order to complete the equation. So we have to do a conversion. From your conversions, you'll know, since we're looking for pounds, we should always start with pounds. So we know already that 2.2 pounds is 1 kilogram. Right? That's just something you need to commit to memory. So we have pounds on the top, kilograms on the bottom. The only piece of information we have is 65 kilograms here. So in order to cancel it, to be left with pounds, we need to put kilograms at the top. So we have 65 kilograms over 1, like I said. Now let's look at what we can do. We can cancel out kilograms, and we're left with pounds, which is what we're looking for. You see that? So then when you multiply 65 by 2.2, you will get 143 kilograms over 1. I'm sorry. You will get 143 pounds. That was pounds over 1. You may need to do rounding, and again, we'll talk about that shortly, but round in the correct way possible, and your answer is 143 pounds. That is the basic example of dimensional analysis. So, taking that information, let's get into the dosage calculation, and we can go through some examples which will progressively become harder or include more information, and we'll see how it works. Okay? I'm going to put all of the questions that I go through on this video in the comments below, numbered, so you can see even through the first 2 examples, there will be 12 questions total. You can look at the exact questions in the comments below if you want to practice this at home. So our first dosage calculation will be a very simple one, and they will progressively get more difficult. The first question is very simple. You have been given a doctor's order for 55 milligrams of, let's call it drug A. On supply, you have a solution which has 20 milligrams per milliliter. The question is, how many milliliters do you give to the patient? So what you always should start with when you are doing dimensional analysis is write out the information that you have, okay? So for the first question, we know that the doctor's order is for 55 milligrams of drug A. We'll just call it that. It could be whatever. And then what you have on supply, we call that often stock supply, what you've got in stock. So stock supply is 20 milligrams per milliliter, right? That's what we've got. That's the only information we've got. The patient needs 55 milligrams, and we've got 20 milligrams per milliliter in our little vial, right? How do we set that up? First, you need to remember to ask yourself, what is the question? What are they looking for? And the question is, how many milliliters do we administer? So we set it up in that way, so we know what we're looking for, which is milliliters. Next, we plug in the information we have. I like to start, as I said, by putting the information that we have so that it corresponds with what we're looking for, which is milliliters. The only information we have that has milliliters is the stock supply, 20 milligrams per milliliter. So we put that in first. Now there's a lot of ways you can do this. As long as you have everything required, you can do it in whatever order makes sense to you. I like to do it in this way because it shows me step by step where I need to go. So let's put in the first piece of information, right? You've got 1 milliliter over 20 milligrams. And that's the same as the stock supply. When you're doing dimensional analysis, it doesn't matter how you do, it doesn't matter whether it's 20 milligrams per milliliter or 1 milliliter over 20 milligrams. As long as you're putting them in correctly and canceling units in the proper way, you can reverse the order of things. That's no problem at all. So you start with what you're looking for, right? So you do 1 milliliter over 20 milligrams, and we've got our stock supply. We're looking for milliliters, so we need to cancel out milligrams, right? And the next piece of information we have is that the doctor's order was 55 milligrams. That's all there is. We can put it over 1, right? Then we cancel out like units, and all we're left with is milliliters, which is what we're looking for. So when you multiply those across, you've got 55 milliliters over 20, and then your answer is 2.75 milliliters. That is what you would need to give the patient from your stock supply in order to get the patient 55 milligrams. It's always important to remember rounding. We've got 2.75. Some tests, some classes, some facilities may require you to round up. In my school, they wanted us to round up to 2.8. They wanted us to round up to tenths of milliliters. Your school may be happy with 2.75. So either one could be correct, but that would be how you would calculate that simple problem. Let's do another one, which is quite simple. Let's say that the doctor orders you 300 milligrams of drug B, and on stock you've got a vial which has 25 grams per 50 milliliters. So let's start by putting the information that we have. So the doctor's order could be a PA or it could be a nurse practitioner. Hopefully it's a nurse practitioner. Sorry, I'm biased towards nursing. That's just a little caveat. The doctor's order in this case is 300 milligrams of drug B. We'll just call it B for now. The other information we have is that the stock supply is 25 grams per 50 milliliters. If you're not in the nursing program, all of this drug talk might be new to you, but imagine that you've got a liquid container of 50 milliliters of liquid, and inside of it are 25 grams of the drug. It's always important, if you've not been exposed to a hospital setting, to think about what are we actually talking about here. So you've got a 50 milliliter bag, let's say, with 25 grams of the drug inside. Let's figure out how much to give to the patient. So what we're looking for, the question here is, how many milliliters do we give to the patient to get 300 milligrams in them? And in this question, the doctor's order includes milligrams, but our stock supply is in grams, so we'll have to do a conversion from milligrams to grams. Okay, so remember to start by writing out what we're looking for, which is milliliters. The first piece of information we can include, which includes milliliters, is the stock supply. So we have 50 milliliters per 25 grams. Okay? Next, I like to convert before I put in the next piece of information. You can first put in the next piece of information and later convert. It's completely up to you. I just like to get my conversions done first. Okay? So what we'll do, we know, or we should know, that 1 gram is 1,000 milligrams, right? That's 1,000, not 1,006. So now we can cancel out grams. You see, you can do that later. I like to do it first, just so I'm in order. Now we've got milligrams on the bottom. The next piece of information we have, which includes milligrams, is the doctor's order, which is 300 milligrams. Since that's the only information we have, we can put it over 1. And now let's see. We've got milligrams here and milligrams here. We can cancel both of those out. At the top then, we've only got milliliters, which is what we're looking for. And at the bottom, we've canceled everything out. So when you multiply these across, you've got 50 times 300, which is 15,000 milliliters, right? Because you still have milliliters on top. And on the bottom, you've got 25 times 1,000, which is 25,000. When you do that division, your answer will be 0.6 milliliters. And that's your answer. You would give the patient 0.6 milliliters of this concentration drug so that they will get what has been ordered. Okay, our next set of questions are about reconstitution. Reconstitution is basically taking a powdered drug and adding a liquid to it, either sterile water or normal saline or whatever the order is for, to create a reconstituted liquid. Okay, these are some vials that I have from my lab kit for the nursing program. So in case you've never been exposed to the setting before, this will give you an idea of kind of what you're doing in the program. With reconstitution questions, basically you can be given a drug, and here I have a vial of a drug. This is just a sample drug. It's nothing. It says Practi powder. It's an empty or dry vial with a powder inside. We imagine this is the drug. And then in a reconstitution question, you'll be told to add a certain amount of a liquid to it into the vial. And then you would, you'd shake it, reconstitute it, and basically what you're doing is just adding liquid to the powder and creating a liquid form of the drug that you can then give to the patient, either through an injection or an IV or whatever. So usually in a reconstitution question, it will give you the amount of the drug, the dry drug in the vial. It will tell you how much of the liquid to put into the vial, and then it will give you the new concentration. And here's another example I have of what the new concentration could potentially be, which is 5 milligrams per milliliter. So here you can, if you can see, this is a liquid vial. Once you've added the liquid from the syringe into the powder, given it a shake or a mix, then you'll end up with this liquid with a specific concentration of a certain amount per milliliter, which you can then withdraw and give to the patient. That's what we're doing with reconstitution. Okay, so let's give a couple of examples of that. So our first question here is, the doctor orders 250 milligrams of an antibiotic. The stock supply is a vial of 250 milligrams of the drug. Directions say to reconstitute with 1.7 milliliters of sterile water to yield 2 milliliters of the drug. How many milliliters will you give for the correct dose? So for this first example, let's talk through it. I won't do this in each example, but let's see what the question is talking about. So the doctor has given 250 milligram order for an antibiotic. Let's say that here we've got our antibiotic, right? The stock supply. It's got 250 milligrams of the drug inside, but it's dry powder. And the directions say to reconstitute with 1.7 milliliters of sterile water to yield 2 milliliters of the drug. So what you would need to do is to add 1.7 milliliters of sterile water to this vial, mix it up, right? And then you will have a total of, it's telling you, you'll have a total of 2 milliliters of the drug in here. So you've added your sterile water, you've mixed, and you've got 2 milliliters of liquid in here. How much of the drug do you have? Well, as the question says, you've got 250 milligrams in here. Once you add it, you've got 250 milligrams in 2 milliliters, right? So let's move forward from there now that you can kind of see what we've done. And the question is, how many milliliters do you give to the patient to give them the right dose, okay? So we'll talk through that. I won't give that example again. That was just so you can kind of see, in case you have no clinical experience, what the question is talking about. Let's start by putting our information out there, okay? The doctor has ordered 250 milligrams of the antibiotic, right? ABX antibiotic. The stock supply is 250 milligrams. Oops, sorry, 250 milligrams. And to reconstitute, you add 1.7 milliliters of sterile water to yield 2 milliliters of the drug. It's important when you're doing these calculations not to get confused by all of the information that's provided. 1.7 milliliters is only the amount that you need to add to reconstitute. It's not going to be part of your equation because it doesn't matter. Once you add it to your vial, right, like I said, add it to your vial. It doesn't matter what the 1.7 milliliters were. Nobody cares anymore. What you care about is what's in here and what's the concentration. Well, you've still got your 250 milligram stock supply, right, which is this. But what we are looking for is what do you have once you have reconstituted it. And it has told you that you have now got 2 milliliters. And inside are still the 250 milligrams of the antibiotic. Okay? So in your dosage questions, you might have a lot of information, and you always have to look at what is important and what is not. The 1.7 milliliters that you added are no longer relevant once you've added them. Now you simply have 2 milliliters solution with 250 milligrams of the antibiotic inside, right? So let's set it up. The question is, how many milliliters will you give? And after you have reconstituted it, it's pretty simple. Let's plug in the information that we have, starting with milliliters, since that's what we're looking for. Let's start with 2 milliliters over 250 milligrams, right? That's the stock supply. And then add the next piece of information, which is the antibiotic, which is also in milligrams. So we'll put it here, 250 milligrams over 1. It's that simple. You'll end up with 500 milligrams over 250, and that equals 2 milliliters. I jumped ahead a bit, but you can see from here you can cancel out milligrams and milligrams, and all you're left with is milliliters, which is what you're looking for. And then you don't even have to write this in here, the milligrams, if that confused you, sorry, because what you'll have is 250 times 2 milliliters, sorry, over 200. And then you divide those, and you'll end up with 2 milliliters, right, over 1. And that is your answer. So that is what reconstitution questions are all about. Taking a dry drug, powder, with whatever liquid is ordered, giving a mix, right, and then you're left with something new, a liquid which has a concentration, and then plugging it in. Okay, let's look at another reconstitution question here, which will add a little bit more information. So the question is, the patient is to receive 500 milligrams of ampicillin. The drug is supplied in a 1 gram vial. Reconstitute with 4.7 milliliters of sterile water to yield 200 milligrams per milliliter. How many milliliters of the drug will you administer? Okay, so what can we do? Let's start by putting our information that we have out. So the doctor's order is for 500 milligrams of ampicillin, right? Okay. Now it says the drug is supplied in a 1 gram vial, and you need to reconstitute it with 4.7 milliliters of sterile water. Now, that's instructions for reconstitution, but that's not relevant for our dosage calculation because we have to do that before that information is relevant, right? Once we have added 4.7 milliliters of sterile water to the 1 gram vial, what we have got, the yield, which we can also call the stock supply, what we've got is 200 milligrams per milliliter, right? Do you see how the supplies that you have on hand, those numbers are not necessarily relevant. What's important is what you've got once you've done the reconstitution. So that's our information. Let's see, the question next, ask yourself, what is the question? The question is, how many milliliters will you administer? Right? So let's plug the information in. 1 milliliter over 200 milligrams. Again, I'm using the information that has the units I'm looking for first and putting those units on top. And then the next and only piece of information we have is the doctor's order, which is 500 milligrams of the drug. So we can put that over 1. You can cancel out milligrams with milligrams, and then we have 500 over 200, and our answer then is 2.5 milliliters of the drug. Do you see how that works? So that is reconstitution. Simple and easy, right? Okay, so we just talked about reconstitution problems. Those are usually having to do with drugs that you might have to give as an injection or either as an IV push. But sometimes the patient, usually or often, the patient will have a constant IV drip going. So our next topic is calculating IV flow rates. There are a few pieces of information you need to know with IV flow rates. These days, IVs usually run through a machine which regulates the rate and the drip. So you need a little bit of information. Usually, orders will come in milliliters per hour, and then the IV pump will administer a certain number of drops per minute. The amount of drops per minute that come through the IV pump depend on the pump, and you'll have that information. The book that I have says that standard drip settings are usually 10, 15, or 20 drops will equal 1 milliliter. But there are also micro drip pumps that will give 60 drops per milliliter. So you have to imagine 1 drop. That depends on the machine. How do you tell how much is in that 1 drop? Well, it depends on the machine, okay? Since we're not in the real world and we're in school, we can't tell what the drop is, so usually our book is going to give us that information. If you're in the real world setting, your machine will tell you how many drops are 1 milliliter. It's also important to remember that drop is abbreviated GTT. Okay, so let's take a look at the first flow rate question. Okay, so it's a two-part question. A lot of times with flow rates, you've got multiple pieces of information to figure out. So the first flow rate question, the doctor orders 250 milliliters of D5W IV every 3 hours. The drop factor is 60 drops per milliliter. Two questions. First, calculate the flow rate in milliliters per hour. And second, calculate the flow rate in drops per minute. So what we know here is the quantity in milliliters that the doctor has ordered. The duration, we know that that amount has to be given every 3 hours. And the drop factor, we know that in our pump, our IV machine, 60 drops from the machine equals 1 milliliter. We need to know how many milliliters per hour the patient should receive, and also how many drops per minute they should receive. So let's start with putting that information in. You'll see the first part will be very simple, and the second part is also quite simple. Okay? So let's see, the doctor's orders for this one are 250 milliliters of the D5W, right, per 3 hours. Now for this, we're working with multiple pieces of information, so it's good to know how much of the drug needs to be administered over what time, and it tells you Q3H, right, every 3 hours. So this is what the doctor has ordered. Not just 250 milliliters, because it's an IV, which is continuously flowing. So we need to know the time, right? So it's 250 milliliters over 3 hours. The drop factor, let's call it DF, is 60 drops GTTS per milliliter. Right? Question 1 is the flow rate, let's call it FR, in milliliters per hour. And question number 2 is flow rate in drops per minute. Okay? You'll see the flow rate in milliliters per hour is very simple. So let's work on it. What we're looking for is milliliters per hour, right? That's right there in the question. So we plug in the information we have. If you look at the information we have, it's already in milliliters per hour, which means it's a simple division question. Let's plug it in. 250 milliliters, right, over 3 hours. You don't even need to cancel anything. You've got it right there. So you divide 250 by 3, and your answer is 83.333, repeating, milliliters per hour. Now you need to focus on rounding. It may be 83, it may be 83.3. My school wanted us to round to the nearest milliliter in flow rates, so our answer was 83 milliliters per hour. Your school might want a decimal. Could be 83.3. Right? Whatever. That was easy. What about number 2? Sorry. I'm looking at my paper, not enough at the camera. Can you see how that worked? Okay. So number 2, we're looking for what's the flow rate in drops per minute. So we're looking for drops per minute, right? So let's take the information we have, which is at the top of the equation. So we're looking for drops per minute. This has drops per mil, so we'll put in 60 drops per, let's say, 1 mil, right, which is what it is. Let's take our next piece of information. So far we can't cross anything out, but we have milliliters down here, and our next piece of information has milliliters up top. So let's plug it in so that we can cross them out. We'll put 250 milliliters over 3 hours, right? Now we can cross out milliliters. And now we have drops per hour. But we need drops per minute, so we need another conversion, right? So we know, so that we can cross cancel, that 1 hour has 60 minutes, right? We can now cross out hours, and we're left with drops per minute, which is what we need. So when you multiply 60 by 250, you have 15,000. Divided by 3 times 60, which is 180. And then your answer is the same. Look at that, 83.3 repeating, which probably rounds up to, actually, it will round down, I'm sorry, to 83 drops per minute. Why was I so sure that it will round down? Because you cannot do a part of a drop. You can't round it to half. You can't round it up. In an IV pump, you either have a drop or you don't. So if it's 83.3, odds are you're going to round it down to 83. Those machines are very, very specifically calibrated. You can't do a half a drop. It's going to drop or it's not. And then you have 83 drops per minute. And that's how that goes. Okay, so now that you see how flow rate problems go, let's do 2 more examples that might include different information. The first one, let's use a nurse practitioner this time. The nurse practitioner orders 4,000 milliliters to infuse over 24 hours. The drop factor is 15 drops per milliliter. And the 2 questions are calculate the flow rate in milliliters per hour and calculate the flow rate in drops per minute. Okay, so let's give the information that we have. The nurse practitioner has ordered 4,000 milliliters over 24 hours. And that's the doctor's order, or the nurse practitioner's order, right? Okay. The next information we have is that the drop factor is 15 drops per milliliter. Right? That's all we have. The 2 questions. One is calculate the flow rate in milliliters per hour. And 2, calculate the flow rate in drops per minute. Okay? Let's see. Let's start with number 1. We're looking for milliliters per hour. So let's write that out right from the start. First piece of information that we can use. Technically, we could use either one. This is where there's a little bit of flexibility. You can use either one, but you'll see that the flow rate is in milliliters per hour. Our doctor's order is also in milliliters per hour. So although you see milliliters over here, it's irrelevant. We've got all of the information we need right here. So let's write that out. The doctor's order is 4,000 milliliters over 24 hours. And guess what? It's just another division problem. That's it. We've got everything we need. So it's 166.6 repeating, which probably is going to round up, but it's always based on your school and your class's policy, to 167 milliliters per hour. So the doctor wants you to get 4,000 milliliters over 24 hours. You're going to set your pump to run at 67 milliliters per hour. What about drops per minute? Let's set up the second part. So we're looking for drops per minute, right? So let's look at our, since we have drops on top here, let's look at the information that has drops on top, and that's 15 drops per milliliter. That's our drip factor. Let's see what else we can put in. And that's 1 milliliter, obviously. Since we have milliliters down here, we have another information which has milliliters on top. So 4,000 milliliters over 24 hours. 24 hours is the doctor's order. Let's cancel out milliliters. And we have drops per hour. But we need drops per minute, so we need a conversion. Since hours is in the bottom, we'll put it in the top. 1 hour equals 60 minutes, right? We can cancel out hours, and suddenly we have drops per minute, and that's what we're looking for. Then you multiply 15 by 4,000, and you have 60,000. And on the bottom, we multiply 24 by 60, and you have 1,440. And when you divide that, you will end up with 41.666 repeating, which will probably, not probably, but surely, I declare, round up to 42, because you can't have 0.6 of a drop. It's either a drop or it's not, right? In an IV pump. So that works out to 42 drops per minute. Sorry, I keep doing that. My paper is bigger than my screen here. You see that? So you end up with 41.6 repeating. You can't have 0.6 of a drop. It's either a drop or it's not. So then you have 42 drops per minute. Okay, the last section of my pharmacology book is called Multiple Factor Advanced IV Problems. These are just questions that put everything together so that you have multiple pieces of information and you may have to do some conversions. So it kind of pulls everything together. So let's do 2 of them and then we'll be done and you will be well on your way to passing your pharmacology dosage calculation exams. So the first question is, the doctor orders vancomycin 2 milligrams per kilogram IV, Q12 hours for an infection. The stock supply is vancomycin 500 milligrams per milliliter. The patient weighs 75 kilograms. How many milliliters will you administer for the correct dose? Okay, so we've got several pieces of information here. Let's start with the doctor's order, which was, let's see, 2 milligrams per kilogram of vancomycin, right, over 12 hours. The stock supply, what we've got, is 500 milligrams per milliliter. And another important piece of information that we need to know is the patient's weight, which is 75 kilograms. So patient weight is 75 kilograms. Can you see that? Okay. So that's the information we've got. We also have information about that it needs to be given every 12 hours, but we're not looking for flow rate, so durations here, we're just looking for how many milliliters for the correct dose. So the duration or the time is not relevant for us right now. What we're looking for is how many milliliters will you administer. So let's look at that. Okay, milliliters. Let's see. The first piece of information, which includes milliliters, is 1 milliliter is 500 milligrams. That's what we have in the stock supply, right? So we'll put that there. So then we've got milligrams here. Let's see what we have that includes milligrams. That's the doctor's order, 2 milligrams per kilogram. So we'll put 2 milligrams on top and 1 kilogram on the bottom. We can cancel out milligrams here. We're now at milliliters per kilogram. We have to get rid of kilograms. What do we have next? The other piece of information is the patient weighs 75 kilograms, right? So we put 75 kilograms here, and that's all we have, so we put it over 1, and then we can cancel out kilograms, and then you'll see we have milliliters, which is what we're looking for, and on the bottom, we've canceled out all of our units. Okay, so when we multiply that, we have 75 times 2, which is 150 milliliters, right, over 500. And if we divide that, we're going to end up with 0.3 milliliters. So the amount that we need to give the patient is 0.3 milliliters. Not too bad, right? We have a lot of information, but we can process it. Let's look at the last piece, the last question here. It's a two-part question, and it kind of puts everything together. And in most pharmacology or dosage calculation questions, you're not going to get any more difficult than this one. This is kind of the maximum. So let's look at it. The doctor orders 600 milligrams of a medication in 300 milliliters of D5W IV to be infused at 6 micrograms per kilogram per minute. The patient weighs 198 pounds, and the drop factor is 20 drops per milliliter. Calculate the flow rate in milliliters per hour, and calculate the flow rate in drops per minute. Okay? So we've got our question. Let's look at the information we can put together from the beginning. First of all, let's put the doctor's order. The doctor ordered 600 milligrams, right, in 300 milliliters of the D5W, right? So we've got 600 milligrams in this bag of 300 milliliters of fluid. Okay, that's what the doctor ordered. The infusion time, let's call that infusion time, is 6 micrograms per kilogram per minute. Okay? We know that the patient weight is 198 pounds. And the drop factor, sorry, I'll put it down here, is 20 drops per milliliter. Okay, so we've got several units here, several pieces of information. Let's put it together. The first question is flow rate in milliliters per hour. Okay, that's what we're looking for, is milliliters per hour. Okay, let's see. The first piece of information we can add that includes milliliters is the doctor's order, which is a good place to start. So we have 300 milliliters per 600 milligrams. Again, we can switch the order as long as we end up with everything in the right place. Okay. Now, we've got milligrams here. over here in the other information we've got, it's micrograms. So we have to do a conversion. We'll know that 1 milligram equals 1,000 micrograms, right? So that's our conversion, and now we're gone. We're done with milligrams. Now we're in micrograms at the bottom. Let's see what else we can do. We have this piece of information that includes micrograms. Now, since micrograms is at the bottom, let's put 6 micrograms at the top. Now we can put the rest of this information, kilograms per minute, at the bottom because we can still cancel things out later as long as they're in the right place. So we can say 6 micrograms per kilogram per minute. Now you can do it that way. Okay, that's no problem at all as long as we cancel everything out. So you've got micrograms and micrograms. We'll cancel that out. And at the bottom you've got kilograms per minute. Now the patient's weight is in pounds, so we need to do another conversion, right? We have kilograms here, we need pounds. Since kilograms is at the bottom, let's put it at the top, and we know that 1 kilogram is 2.2 pounds, right? So we can cancel kilograms from here, cancel it from there. Now the only things we've got left here are minutes and pounds, and we need hours, right? So let's get rid of minutes. Since minutes is at the bottom and we need hours, let's say that 60 minutes are in 1 hour. The next thing that we need to do is add the final piece of information, which is the patient weight, which is 198 pounds. Since that's all, we can put it over 1, right? And we've got cancel out pounds and cancel out pounds. Now, that was a lot of conversions and information, but if you can see it there, let's look at the top. We've canceled out everything from the top except for milliliters, which is what we need. And at the bottom, we've canceled out everything except for hours, right? Which is also what we need. So then it's a question of doing our multiplication across the top and our multiplication at the bottom. Let's see. At the top, when you multiply 300 by 6 by 60 by 198, you're going to end up with a big number, which is 21,384,000 over, when you multiply 600 by 1,000 by 2.2, you'll get 1,320,000. Don't be scared by big numbers because you cancel all of them out. So the final number you'll get is 6.2 milliliters per hour. That was what the question was. How many milliliters per hour will the patient receive? Okay. Let's look at the second part. And then we're done, then you've survived. The second part of the question is, what is the flow rate in drops per minute? Okay, so let's look at drops per minute. We'll go ahead and do like this. So our drops per minute. Let's start with the information that includes the drops. And that's here. The drop factor is 20 drops per milliliter. So we have 20 drops per milliliter. That's 1 milliliter. The next piece of information, since we've got milliliters here, we can look at what else has milliliters, and that's the doctor's order. So we can do 300 milliliters over 600 milligrams. And again, you can switch the order as long as you're cross-canceling everything you need to. We'll go on to a second line for this one because it's a big one. Let's see, we've got milligrams here, right? And we need micrograms because the infusion time is in micrograms. And here we have milligrams. So since milligrams is at the bottom, we'll put it at the top, and we know that 1 milligram is 1,000 micrograms. right? Let's do a little bit of canceling to make it clearer for us. We're looking for drops per minute. We can cancel out milliliters. We have milligrams at the bottom here and at the top here. We can cancel those out. So now we have micrograms. Let's take the next piece of information. We still have the infusion time, 6 micrograms per kilogram per minute. So let's do 6 micrograms on the top per 1 kilogram per minute. Okay, we can then cancel out micrograms. Let's look at the next piece of information. We have kilograms at the bottom here, but in the patient information, the weight is in pounds, so we need to convert, right? We know to convert, since kilograms is at the bottom, let's put it at the top. 1 kilogram equals 2.2 pounds. Do you see that? Okay, so we can cancel out kilograms and kilograms. We have to deal with minutes and pounds here. So the next piece of information we have is that the patient weight is 198 pounds. Let's put it over 1. And we can cancel pounds with pounds. I know that's a lot of information, but can you see? We're looking for drops per minute, right? Let's see what we've canceled out. We've canceled out on the top everything except for drops. Let's see, drops, which is what we're looking for. On the bottom, we're looking for minutes, and we've canceled out everything except for minutes. So we know that we've gotten to the right information. Then we just have to do our calculations. 20 times 300 times 6 times 198. Again, you have a big number, don't worry. 7,128,000. When we look at the bottom, we've got 1 times 600 times 1,000 times 2.2. It equals 1,320,000. When you divide that, you end up with 5.4 drops per minute. Remember, with flow rates, you either have a drop or you don't. So normally, check your rules, but usually you would round 0.4 down. So it would round down to 5, and your answer would be 5 drops per minute. Do you see that? How we came to that? And that completes our lengthy dosage calculation tutorial. Okay, so that was my video on dosage calculations. I hope it was useful. I hope that you were able to see. This was an experiment in webcam filming and editing for me. But if you have any other specific questions about dosage calculations, feel free to send me a message. Like I said, I'm not an expert, but for me, using dimensional analysis, it was pretty clear and foolproof on how to do it. And so I hope it helped all of you. I know it was very long. This was not meant to just be a watch this video and be entertained kind of thing. I know it was very long, but it was hopefully a tutorial for anybody who was really looking for information on how to work through dosage calculation. So that's it. Take care, and I hope to hear some feedback from all of you guys. Okay, bye.